Hi, folks. Great to see you. I hope you all are doing well, feeling energized after lunch on the third day. Great to see you here, also in the room with a window. I was very happy about that. Not only because I work on Microsoft and like the Windows joke, because sunlight, right? I'm Scandinavian. Cool. We're gonna dive into architecting for a greener future. Now, I've talked about green software for a few years now. And in the beginning, I would always start with some kind of graph showing the CO2 concentration in our atmosphere or the ocean warming, anything like that. But I am done with that. I'm done talking about the problem. There are other people who do that much more eloquently. You came here, so I'm going to assume you are on board the whole climate change situation. And if you're not, you can go look that up after this session, because we're going to talk about solutions today. I'm interested in the climate solution. So that's what we'll be focusing on. So who am I? My name is Sara Bergman. I am a Swede living in Norway, and I usually say that doesn't matter to anyone living south of Denmark, but being at Øredev, I'm guessing there's a lot of people who live north of Denmark, so you might care about that information. I am a senior software engineer at Microsoft. I have been working a long time on M365 products, but currently working on efficiency I recently switched teams and I don't have a good elevator pitch for it yet. So I need to work on that. Efficiencies at cloud scale is like our tagline. Anyway, I'm also a speaker and advocate for green software practices within Microsoft, but also externally. I do things like this a lot. I am an author of a fairly new O'Reilly book called Building Green Software. So if you want to know more after this talk, you can go read our book. I also have a kid who just started kindergarten, so I am sick because apparently that's what happens when you get a kid and they go to kindergarten. You're sick for like 6 months. Some people nodding, you know my struggle. So that's why I had this nice whiskey voice. We're just gonna hope it lasts through the entire 40 minutes. And also I forgot to start this. Oh no. I have two extra minutes now because that's how you do it, right? No. Okay, sorry, enough about that. Let's dive in. So green software, where are you? When you think about sustainability and your corporation, it's very easy to go like, am I good, bad? But actually this is like a multifaceted problem. Sustainability is not just one thing. So a good way to answer the question, where are you now as an organization, can be tricky. And there are many ways you can answer it. I like to use a tool from the Green Software Foundation. Now, if you haven't heard about them, they are 3 years old. And Microsoft was one of the founding members, but now there are over 60 members. And their mission is to build a trusted ecosystem of people, tooling, standards, and best practices within green software. They have lots of different things that come out of this foundation. So not only standards, but there are also SDKs, there are hackathons, there are local meetup communities, there is a podcast. So if you are not sick of hearing me after these 40 minutes, you can go listen to me occasionally jap away at their podcast. They sit under the Linux Foundation, so it's non-profit. The members are a mix of academia, non-profits, and for-profit companies. And one of the things that came out of this is the Green Software Maturity Matrix, which is a tool we're going to talk a bit about. Now, maturity matrices aren't new or specific to software. They have been used widely around different industries as a way to assess where you are in terms of best practices and what you can do to achieve a higher level of performance. The Green Software Maturity Matrix specifically is a framework for assessing the level a tech organization is prepared to handle the energy transition. If you don't know what the energy transition is, don't worry, we'll talk about it. But first, let's talk about the different levels you can be on in the Green Software Maturity Matrix. First is aspiring. You have processes that are unpredictable, maybe poorly controlled or reactive at best. You have some individuals within your organization who care about green software and like maybe measuring their own team's footprint, but you're not doing a lot. On aware, you're starting to become aware. So you know your organization's scope 1 and scope 2 emissions. You have a few projects driving greenness. That's not only doing that for myself, but also using like the results and learning from that. you're often still pretty reactive at this stage. On acting, now you're finding your feet. You're good here. So you have some decent basic org-wide data, and you apply that data across your organization. On level 4, awesome. Now you are awesome. So you have measured and controlled processes, and you can measure your progress towards your carbon goals dynamically. And that means that you have access to real-time data. On level 5, inspiring. You are a beacon of light to our industry. You have continuous improvements that occurred based on quantitative feedback. You are driving not only your footprint down, but the footprint of your customers to go down. And you're optimizing for minimal emissions using dynamic real-time data. Now this is a matrix, so there are not only levels, there are also different columns, as you can see. Commitments, footprints, metrics, carbon ops, energy, devices, utilization, products, and training. It's a lot. Every column of this has a specific action tied to it. The full one is available. I have a link at the end if you are curious, but we're not going to talk only about this, so I have blocked them out for now. What's interesting to notice here or to think about is that you may be very far ahead in some categories and not so far ahead in other categories. It's a matrix, like I said, so you don't have to be on level 5 in everything, right? Or you maybe want to be on level 5 in everything, but you might not be. You might be there in one category and not in another, for example. Now it's easy to, again, look at this and see, great, perfect. Finally, I have this tool that I can show and tell people how ethically good I am and how I am a shining light of hope and everyone should be just like me. And that's not what this tool is for. This tool is a concrete risk mitigation strategy. It's a way to provide a resilience against a bunch of things that we're seeing happening globally. One thing is the tightening environmental, societal, and governance and other like EU reporting requirements around sustainable IT. We're also seeing a massive increase in physical disruptions to IT systems due to extreme weather events that are directly caused by climate change. If you just look at what happened in Florida just a few weeks ago. We're also seeing pricing changes. So electricity is one of those things that has very dynamical, widely varied pricing tariffs, something that was painfully obvious for those of us who lived in the European Union or EU. Sorry, why did I say the same thing? In Europe during the energy crisis a few years ago. Globally, we're also seeing a bunch of new legislation around repair and reuse, reduce, recycle rules, which we're going to have to adapt to. It also ties into hiring and retaining employees. We're seeing more and more that especially the younger generations really want to work at a place which aligns to their values. Okay, so the kicker is almost all of us are at level 1 right now, the whole kind of floundering phase. And we need to be higher up the ladder, preferably a lot higher, a lot faster. Now going to 5 is a very long-term project, and we only have 40 minutes, so I don't have any secret tips today for how you can get there. However, I will talk about actionable things that you can do to move towards level 2 and 3 in 2 of the categories, because again, the matrix is pretty big. So where do we begin? If you are a software practitioner of some kind, an architect, an engineer, PM, manager, whatever your title is, and you want to start moving up those ladders, where should you start? A lot of people say this. This is something, especially in the beginning, people would like hopefully come up with me afterwards. Does this mean I can rewrite my entire code base in my favorite language that's much more efficient? And they were like, please say yes. And code efficiency can have massive gains. There's no doubt about that. There's lots of research to back that up. However, writing efficient code, it's like on that level of efficiency, is very hard. It takes a long time. It's not new to our industry also. High-performance computing has been around since the 90s because we had to do it because our computers were small. I say we, but I was barely born in the 90s. So yes, I've heard stories though. So the thing about this is writing this high-performance code, it's hard, take time, lowers developer efficiency. Because it takes a longer time. It's also more difficult to maintain and add newer features. And that means developer efficiency goes down. And for a lot of our companies, developers are super expensive. Like we make up a really big budget post for our finance team. So they don't want us to do anything that makes us less efficient, or that means we're not going to deliver business value for an extended period of time because we're saving the planet. It's just not going to fly. So as a first step towards being greener, it's not a great option. If high performance computing is already mission critical for you, maybe you're still working on tiny like chips, FPGAs, for example, then you're already doing this. You don't need me to tell you it's also greener. But if it's not mission critical for you, do the small efficiency improvements, yes, always, but don't rewrite your entire code base as your first step on your green journey. Okay, so is it data centers then? Should we start there? And yeah, we already have. So this has been an ongoing research area for a very long time because guess what? Data centers, very expensive. They eat energy like there is no tomorrow, and materials and servers. And yes, so they're expensive. So therefore, we're seeing this shift move from local data centers that are kind of less efficient to more hyperscale data centers that are much more efficient. All of the cloud providers, the major three, announced that their PUE, so their power usage effectiveness, it's a ratio between how much energy goes in versus how much goes to meaningful compute and how much goes to auxiliary things. So 1 is perfect. That means all energy that goes in goes to meaningful compute. All new data centers for the hyperscalers are now pretty close to 1. So that's nice. So what you can do is, of course, use your spending power. Choose a cloud provider that's aligned with your ambition. But meaningful compute, what is that? Well, that is up to you. So you're not off the hook. Cloud users are still responsible for the sustainability of their workloads inside the cloud. So where should you start? Well, I want to argue that operational efficiency is a good place to start. It's a worthwhile effort. It's completely within your control. You don't have to wait for anyone to build this amazing air-run data center that runs on pixie dust or whatever. You can start today. You can start now. And oftentimes here, small efforts can have big wins. And as a bonus, you often end up with a cheaper and more performant service as well, and more resilient. So good news all around, I guess. Before we dive into how you do that, let's talk about what makes software green. I've said green software a few times. What do I mean by that? And the first, or the overarching thing here is carbon efficiency. Green software is carbon efficient software. Emit the least amount of carbon possible. There are 3 different ways or sub-areas to how you achieve that. The first is energy efficiency. Seems pretty logical, right? Use less energy, greener. Secondly is use your hardware more efficiency. So be hardware efficient. Use the least amount of embodied carbon possible. IT equipment, things like servers, takes a lot of materials and energy to produce them and then ship them around the world and assemble them and then ship them to whatever they're going to end up. And we as software people need to be responsible of that depth when it lands in our hands. Now you may say, but I'm a software person. The hardware problem is for the hardware people. I'm a software person. The thing is, your software has a great impact on not only what type of servers your asset team needs to buy, but also what type of software your clients need to buy. Say you have a product that is essential for, like you have a bank app, for example, or something that's your customers really, really need. If you say we're only going to function on the absolutely latest version of an iPhone, then you're essentially saying to everyone who doesn't have that type of phone, well, you need to upgrade. And you're creating a bunch of e-waste simply through your software updates. So you're not off the hook. And the next, carbon awareness. That means doing more when the electricity is clean and doing less when the electricity is dirty. And we're going to dive a bit more into this over the talk as well, because it may sound a bit sci-fi. But being carbon aware helps decarbonize the grid both now because you're using more low carbon sources, but also over time because you're putting money into the pockets of people producing that low carbon energy. Fantastic. Back to operational efficiency. Show of hands. Have you heard of energy proportionality before? Yes, nice. One. Thank you. So this is from a paper published in 2007 by Google engineers Luis Andres Barroso and Urs Hösele. And they did this study where they basically observed it to see how much energy is a server consuming when it's just idle. Turns out a bunch, like a lot. So even if it's just sitting there doing nothing, it eats a lot of resources. And then it kind of scales with utilization. And this graph is not perfect. It's kind of an abstraction from their paper, but roughly this is the relationship. So when we talk about operational efficiency, this is a key thing we want to minimize. We don't want to have a bunch of servers that like 2 or 3% utilized, because then we're paying the startup cost for every single server. We want to have appropriately utilized machines so that we are very mindful of this startup cost. Now in this paper, they produced they suggested something called energy proportional servers, where this would start at 0, which is super cool. Still very much a research project. We are nowhere near being able to do that kind of hardware, but that will be super cool. So, hopefully in the future. Another thing that's key to green software is the energy market, and this is where we're going to dive into the carbon awareness side of things as well. So there are two sides that of the energy market that matters to us. The first is how is electricity generated? Different means of generating emits different amount of carbon into the atmosphere. Are you using coal or are you using hydro? I think that's something we all feel comfy with. The second is the price. Because electricity or energy is a commodity that you can trade on, people trade on it a lot. So the price depends on multiple factors. One is supply and demand, because energy or electricity is kind of unique in that sense that supply always has to meet demand. Because if we have more supply than we have demand, a lot of very expensive things on our grid break. And we don't want that. So what happens is they then dump it. No one uses it, which is bad, which is why sometimes you can even get paid to use electricity because there is a surplus, which you might have noticed as a consumer, but it's very much true on the data center side as well. Cost is, of course, also determined, like how much does it cost to generate this type of energy? Do you need a fuel or not? As well as weather conditions. And this is the coolest graph I'm going to show today. So if you only take one thing away, let it maybe be this. But this is what's happening now around the world. Renewables are on the rise a lot. Our electricity grids are in the process of becoming revolutionized. These always on fossil fueled gas, coal plants are being replaced by cheaper but more variable renewables. We're seeing more and more countries have low carbon energy for longer periods of time, and as a result, they have free electricity for parts of the day or parts of the year, especially in very sunny countries where they have a lot of solar. The thing about renewables, though, is that they are kind of spiky. The sun isn't always shining, the wind isn't always blowing. And going green is not just about battling climate change, but it is adapting to that new kind of reality where the electricity price and availability is going to be much more variable than what we're used to right now. Because even if you don't believe in climate change, and if you don't believe in any of this, this will happen anyway. Like, this is unavoidable at this point. So we're all going to have to adapt to it, whether we like it or not. Cool. So what can you do then? Back to software. Back to the Green Software Maturity Matrix. I am going to focus on these two categories, carbon ops and energy, because they have a lot of those architectural concepts. There are other things in here if you're interested. Like, you can read up afterwards, but we're going to do this. Also, I read all of the cloud providers' well-architected frameworks sustainability section, so you didn't have to. I still recommend you do it because it's a good read, but I summarized it for you. I also want to take this opportunity to plug the Cloud Native Computing Foundation's environmental sustainability tag. I don't know why everyone has such long names. Like, we need more shortened names. Anyway, they have a technical advisory group, a tag. And the goal for them is to advocate for, develop, support, and evaluate environmental sustainable initiatives in cloud native technologies. So they have a bunch of stuff. They have like some best practices for communities clusters. They're also assessing the footprint of the other CNCF project, etc. So if you're working a lot on cloud native stuff, you can go check them out. They had in the middle of October like a sustainability week where they did a bunch of local events and global events, which are still live. So that's a recommendation as well. Okay, enough about that. Let's get to the stuff. Carbon ops, server resource management is what this boils down to, and it has a lot to do with carbon efficiency. The first thing is to not be Smaug. And Smaug, if you don't know, is the dragon in the Hobbit from Lord of the Rings universe. And he is a dragon. He sits on a mountain. He has a big old treasure. He does not share. Like, it's his treasure. Also, he doesn't do anything with the treasure, so it's truly a waste. And you don't want to be that person. So what we want to do is avoid hoarding. You want to delete your unused and idle resources, your old logs, your unused data, any zombie workload. So a workload that's just going, delivering no value. Yeah, delete it. And this is also a great way to save cost, both in the cloud, but also if you're on premise. And this is easy to achieve, right? It didn't take me long to write this slide because I didn't have to draw the dragon. There was like an image I could just use. So it didn't take me a long time at all. It's harder to achieve though, right? We're not keeping things there for the sake of it. There's typically a reason why we didn't delete it. So we want to think about how we can orchestrate this. And this is in some sense a technical problem with maybe an organizational solution. One thing is retention policies can be a very useful tool in your way of combating this. FinOps is another great broader strategy, so sort of follow the money and try to optimize cost. That typically also removes a lot of things. Another thing that's a key concept here is this fantastic notion of light switch ops. It was a concept coined by Holly Cumin in QCon London in 2003, I want to say. Yes. And the idea behind this is that when you leave a room, you turn the light off and you feel very confident that if you ever need to go back into that room, you can turn the light on again and the electricity will be there. Turning turning a workload off should feel just as safe. You should be able to do it and trust that when you need it, it will come back online. So that is a good mental model to use. And there are many concepts to this, but one of the guiding principles is that you should make it easy for people to get what they want. That may sound counterintuitive if I give everyone what they want they just like hoard and have everything. But let's consider the opposite. Say you instate this formalized process. So, hey, Sara, you wanna get a new testing environment. Great, fill out all of these forms for me, and then I promise I will give you an environment. Great, so I do that. I take time away from the thing I like, which is writing code, fill out documents, which I don't think is very fun, and then I finally get this testing environment. Great. Do you think I will let it go? No, I will hold on to that thing for dear life. I might never use it again, but maybe I'll use it in a month, maybe in a year, and I don't want to fill out all these papers and forms again. That was boring. I want to code, so I will keep it forever. Now, if I can get my testing environment by the click of a button, I have no problem releasing it. I'm happy to give it any resource back because I can get a new one when I need it. So make it easy for people to get what they want to minimize waste. Okay, this is where I pledged allegiance was always, no, that's not what I wanted to say. I come out as a backend engineer, is what I'm trying to say, which is why my drawings are terrible. But one concept that's important when you think about architecture is the concept of the right sizing. And here you have a workload that is not right-sized. So you have a physical server, and within that you have a container, and you have your resource use. If you're using less than what you provision for, no one else gets to use those resources. They're just assigned to you, but they're not being used for meaningful compute. So what you instead want to do is this. You want to right-size your containers. You want to only use or provision the amount you actually need. Because what then happens on the background is, look, I fit another one. Remember that graph with the energy proportionality? Now we don't have to have 2 servers that are like mildly utilized. We have 1 server that's utilized at a good level instead. And that additional machine can be used for other things. So this saves energy due to the energy proportionality, but it also saves embodied carbon over time, because capacity planning is a very long-term project. When you plan for capacity, that's like the notion of we will probably have more needs in the future than we have now, which is like based on historical data. What most people do is they look at, okay, how has demand increased the last X time? Based on that, we project how it will increase in the future. And if everyone is constantly over-provisioning, the signal you're sending is more. I need more. There is not enough. Whereas if everyone's right-sizing, you're actually sending the correct signal, and the capacity planning will be more scaled towards the actual needs. It's also cheaper if you end up using a smaller instance compared to a bigger instance. You save money. Great. It's easier said than done. Also, you probably need some analysis to see how much do I actually need. I tried to fit all of the different options for VMs that cloud providers have. It did not fit. There are a lot of options. So I know it can be tricky. But one way to do this can be auto-scaling. So this is the same graph as before. We've just added demand. I'm talking about horizontal scaling here. You can do vertical. It's a different beast, so we're not going to tackle it. Most of us are very comfortable with the first thing, like demand increases, we scale up, yay. The second part feels a little scary, letting go of stuff. What if the new peak comes? But that's the key. The only way auto-scaling is greener is if you do both. If you auto-scale by only scaling up, it's like greener once. It's a greener first time, then it's not green anymore. A lot of cloud providers have already support for auto-scaling in a bunch of their managed resources, so if you're on the cloud, you can reap the benefits. This is also a great way to provide resilience against spikes and stuff. You, of course, need some way to achieve this. You maybe need infrastructure as code or a cluster scheduler. Great. If you're on the cloud, another thing to think about is to use the most suited tech. Now, a not so secret about cloud providers is that they're big on cost. Data centers cost a lot of money, so they want to provide options that are cost efficient to run and that will eventually be cost efficient to you as well, because it just makes sense for their business. They also have a lot of engineers to spend on engineering those solutions. So you want to think about your scenarios and what you actually need, and then get the right thing for your needs. So one good example is hot, warm, cold storage. Cold storage is pretty cheap. You're using very little resources for it. So don't use a hot storage option if that data can actually safely go to cold storage. It's a great way, easy way to save money and also save the energy. You want to decouple your storage for compute. If you have options where your compute is coupled to your storage and you have to scale your footprint for your peak compute requirements, you may end up with a lot more storage than you actually need. So decouple them so that you can scale them individually. You want to think about platform as a service versus infrastructure as a service. Do you want to manage the infrastructure, or can you use a fully managed server and reap the benefits without any work? Those are important considerations as well. And using the right framework and libraries, they can also have a significant sustainability and performance benefit. So you want to, especially in the cloud, you want to choose those that are well supported and that are optimized for the cloud, so everything hangs together. Serverless is another thing that's being pushed a lot by all the major cloud providers. It's the tagline is kind of like software without the infrastructure. Google have a bunch of options. AWS has a bunch of options. Azure has a bunch of options. Serverless is, at this point, almost a buzzword, right? But what is the good thing about serverless? Well, I like to think of it as a way for you to help your cloud provider be greener. Because with serverless, you're basically saying, I want this thing, and it's up to you to fit that onto the physical machines as efficiently as possible. And that's great, because that's what cloud providers are good at, software at scale. That's their whole business. Your business might be something else entirely. So the benefit of serverless is you give away the control and you let them optimize for energy efficiency, which they will do because it's cheaper. It can also be a way, if done correctly, it can reduce your costs as well, which is always nice. Is serverless the solution to everything? No, it's not always better. Definitely not. It's one of those things where you have to put on your engineering thinking hat and consider, what is my scenario? Does this make sense for serverless? Or am I just using it because I like the buzzword? Cool. You also want to use the most efficient hardware. If you have your own fleet, this might be a tricky choice because you're kind of stuck with the things you buy for a long time. So the most efficient hardware for you can mean different things. Is it like, what is efficiency here? Is it carbon efficiency? Then using what you have might be the most efficient because we've already like paid the environmental cost of that, versus buying something new that's just a little more energy efficient, for example. So it's trickier, but it can absolutely be done. If you're on the cloud, you have the benefit of choosing from a wide array of hardware. So make sure you're making the best out of that choice and not throwing it all away. And what is the most efficient thing here? That has to come down to your workload. For example, AWS have a Graviton processor. For some of their workloads, they are citing like a 40% better performance, which is quite a lot for just lifting and shifting. Azure has the Ampere Alt ARM-based VMs, and Google, if you're doing machine learning, they have their own tensor processing unit. So the reason why this is better is because it's a lot more energy efficient, and that means you're going to utilize that hardware for a shorter period of time, meaning more people can utilize the same hardware. So you get this. Someone said, I like to think of the cloud as the bus versus everyone taking their own car. And I kind of like that thinking. Especially for this scenario, because more people can eventually use it. All right, so I've said efficiency. I don't know. I hope no one makes a drinking game out of this because that will be terrible. But I've said efficiency a bunch of times, and that means someone is going to say, what about Jevons paradox? Now, if you're not familiar with Jevons paradox, you're in for a treat. So the Jevons paradox is William Jevons's historical, he was in economics, and historical observation that when we get more efficient at something, it gets cheaper. And in the long run, we end up doing more of that. So here you see an example. When the cost of fuel is lowered, people travel more. So the overall consumption of fuel is like the same or even more. And people argue that the same will be true for software. We make software more efficient, it gets cheaper, and people use more software. And it's a fair concern. And I have a few feelings around this. Firstly, to doing something that's so massively more efficient. So massively more efficient that our consumers will consume more of it. It's pretty hard. None of the things I said today will like do that for you. I'm sorry. So I think once we get there, the energy transition will be a lot further, and we will have much more access to clean, renewable energy. And that's maybe an optimistic statement, but based on the data, I fully believe so. I fully believe in a few years, we will not worry so much about energy anymore. That will be a lot greener. Secondly, what is my second point here? Right. For most of us, we don't produce software that people can use 24 hours of the day, right? There's like a limit to how much of any type of software you want to use. Like say you made it cheaper for me to, or easier, like to scroll social media, whatever. There's still a limit to how much I want to do that in my day. Then I go on and do something else. Same with like a washing machine. They can make washing machines like a bunch more efficient. I still only have that much wash up to do. There is a physical end to a lot of the things we do with software. So I'm not super worried about Jevons paradox. However, the energy transition is not completed yet. We still have a lot of fossil fuels on our grid. And who knows what will happen now with the latest election in the US. But anyway, so until the energy transition is complete, we need to use less energy. We need to be better users of energy. Cool. So energy, carbon-aware energy resource management. We need to talk a little bit about the greenhouse gas protocol, because there is no way you can escape that for some reason. It's just everywhere. The greenhouse gas protocol is widely used in all industries. It is a way to do kind of carbon accounting. It's more of a finance tool than anything else, but it's very widely used. And then you have market for scope 2, which is how much energy you use. You can report it in two ways. Market-based, where you can have all sorts of financial incentives, like offsets, for example, or location-based. Either is fine of you to use, just make sure you pick the one you need. And for tooling, when you choose your tooling, think about, do I report on market-based or do I report on location-based? Location-based is the actual electrons that you use based on your specific location. Either is kind of fine. I prefer location-based, a lot less confusion. Just tread gently. So what you can do here is time shift. You move a workload to a greener point in time. Anything that's not on demand, anything that can wait a bit, you can move it in time. You can get a forecast from a bunch of those tools I mentioned, and you can see, oh, well, perfect. In 2 hours, the grid intensity is like half of what is currently. I can wait. I don't need my on-demand task to run right now. Big tech is already doing this. Google claim they have been doing this for their media processing for a lot of YouTube tagging and stuff since 2001. You can do the same, but spatially, so moving to a greener place. A lot of grids around the world are different, and they have different energy production throughout the day. But also neighboring countries can have completely different types of energy generation. So look around, talk to your cloud provider, and see if there's a greener option for you to move to. Fantastic. I got stressed because I'm out of time. So where does all of this take us? Well, we have seen that all of these actions, they help your sustainability go up. If you do any one of these things, they will help you move up the Green Software Maturity Matrix ladder. But the good thing about them is they have co-benefits. A lot of them will make you have a cheaper service, which in today's economical climate is a very good thing to go and tell your product manager or your CIO or CFO, whatever, like, hey, I think we should do that not only because it's greener, but also because it's cheaper. Speaking to people's wallets, it helps. Like, I'm sorry, that's just how the world works. But also resilience goes up. Auto-scaling and carbon-aware actions are a great way to future-proof your software as well. So you have two things instead of three things. You have three things instead of one thing to bring up with your product managers. Fantastic. So software they will benefit from carbon efficiency, is my point. And building green is cheaper, more performant, and more resilient. I did have some resources here in case you're interested. I think the slides will be shared afterwards, so you can go and click then. Until then, thank you so much for your time.